Hello, my name is Rivera. I'm the Director of Scientific Outreach here at Meter Group, and today we're going to talk about the SATURO versus the KSAT and focus in on these two different methods. So here we have our two instruments for measuring saturated hydraulic conductivity. We have the SATURO for making those measurements in the field, and then we have the KSAT, which is our device for making the measurements in the lab. And so there are a few differences that you need to understand about the two instruments, and there's pros and cons to both. With both of these methods, you're going to need a water supply to feed either of them. With the SATURO, it's going to be connected to this external port right here that's going to the water supply, and the KSAT is going to be connected to a reservoir in the lab right here that's feeding water. KSAT, it's a really simple device, and the way it works is we have our reservoir here that we're going to fill with water and then infiltrate that water through the sample. What we're doing is infiltrating water through the bottom of the sample. And we have a pressure transducer that we're using to measure the change in the pressure head and automate that measurement of the infiltration rate of the water through the sample. So the water goes through the sample and then outflows over this port right here. And we're going to put this collar back on the sample. And that seals everything up. That way we have no leakage. And you're just going to fill this up with water, turn this knob, and then the device starts taking measurements. And this is going to be connected to your computer where the software is actually doing all of the measurements there. With this instrument, measurements typically take anywhere from a few minutes up to a couple hours, depending on the soil type and how fast the water actually flows through the soil. And you can run through many samples in a day pretty easily. And what's really nice about this approach is you can collect samples from the field and store them for measurements later on. So if you have a lot of measurements that you have to make, this really makes that easier because you can collect those samples and then just have them stored and ready to start making those measurements. Now, when we think about our field instrument, so here we have the SATURO, and again, what we're doing is inserting this ring into the ground, and we're gonna drive this into the ground. This is our upper chamber where we're doing some of the controlling from. So in this chamber, we have an air port and a water port, and then we have a level sensor. The level sensor is monitoring the water level, and we're trying to maintain a constant water level of 5 centimeters. And then we're adding water from this main control unit here. That is the brains of the device that actually does all of the calculations on board as well. And this device is pumping water into the chamber through this hose here. Then we're actually using an air line to control the hydrostatic pressure above the water column in the SATURO. And what that allows us to do is actually infiltrate water at two different hydrostatic pressure heads. And in doing that, we are actually able to calculate the sorptivity of the soil, and that allows us to simplify the approach of how we're correcting for three-dimensional flow from this device. So when water's infiltrating through this, it's not just going down vertically, it's also going out laterally. And so we have to make that correction. But with that dual head approach, that simplifies how we make that correction. Measurements with this typically take anywhere from an hour to 2.5 hours, depending again on how fast water is infiltrating and how long it takes to reach a steady state in the field. The time that it takes to complete a measurement, again, is controlled by quite a few things, but one of the most important ones is the initial water content. If the soil is closer to field capacity initially, typically the measurements are a little bit faster, but also soil texture can play a role there as well. Finer textured soils like clay can tend to take a little bit longer to make a measurement and get to that steady state value. But what's nice about this is when it's done, it actually does all of the calculations on board to do the corrections for three-dimensional flow and give you a final field-saturated hydraulic conductivity. And I just want to point out one other difference. You'll notice when I talk about the SATURO, I use the term field-saturated hydraulic conductivity, and when I talk about the KSAT, we just call it saturated hydraulic conductivity. And one of the reasons we do that is because in the field, it's hard to actually get the soil to full saturation. You usually wind up with entrapped air. So when we're making these measurements, we usually refer to those as field-saturated hydraulic conductivity, whereas in the lab, it's a lot easier to actually fully saturate a sample and get to that saturated point where we can refer to that as KSAT. Both the SATURO and the KSAT are great tools for making hydraulic conductivity measurements. But like we just discussed, there are differences between the methods that you need to take into account when trying to decide which one you're going to use for your research and for your measurement goals.